Okay, so good afternoon once again. So my name is Ikechukwu Achom. I'm a mobile developer. Uh, I build native and cross-platform applications, right? So welcome to KodeCamp 4.0. This is the first class of our intermediate Flutter training. So we'll start by looking at some advanced Dart concepts. Basically, we're going to be just talking about, we'll just do an intro to OOP, right? I believe you know what OOP is, right? Of course, as intermediates, people who have actually brushed through beginner stuff, okay? And of course, part of the requirements that you have knowledge on that. Or just brush through some of these concepts, right? Um, and we'll go through talking about object-oriented programming, which is OOP, right? So let's probably just start with, definitions, right? What is OOP? Is there anybody that can, just help us out? What is object-oriented programming? So part of what we're going to look at today, probably this week, is OOP, and then we'll talk about generics and asynchronous programming. So is there anybody that wants to assist? What is OOP? You can raise your hand or drop it on the chat. OOP, anybody, or do you want to rush to pick up something online? Okay, so don't worry, let's get to it. Okay. So yeah, I remember when I heard, okay, someone's hand is raised. Okay, Collins, have you dropped it quickly? So that was so fast. Okay, don't worry, let's just run through. Okay. So let's try to explain OOP. I'm going to break it down. Okay, someone says a programming paradigm where concepts are represented in objects. Okay. So the word object-oriented, if you check it, if you look at it, is a combination of two terms, right? Object and oriented. And if you check the dictionary meaning of objects, it will tell you that object is an entity, right, that exists in the real world. Okay. And oriented means, interested, kind of like just say interested in a particular kind of thing or entity. So in basic terms, OOP is a programming pattern that is built around objects or entities. That's why it's called object-oriented. Okay? Object-oriented programming. So to let's see, to better understand this concept, let me use let me use this illustration, right? A good example to explain OOP, right, would be the use of a printer when you are printing a document. Okay, a printer when you're printing a document. Now, the first step is initiating the action by clicking on the print command, right? Or maybe using a keyboard shortcut, right? The next thing you have to do is select your printer. Afterwards, you now have to wait for a response that tells you if the document was printed or not, right? This is something we can relate with. So behind what we can't actually see, the command you clicked actually interacts with an object, which is the printer, to accomplish the task of what printing. Okay, so that's kind of just like what's that? I'm trying to that's kind of like an illustration. Okay, now OOP actually became popular, back in the 60s, with a programming language called Simula, right? Um, even though from the research, right, I did, right, developers didn't really embrace the first advances of OOP languages, the methodologies that was actually what's used, but it actually evolved right down to the 80s. I think that was his name, David Robinson, was one one of the first introductions to OOP, right? It was actually written by David Robinson rather. Okay, so OOP is actually the structure of OOP programming is basically has to do with what? Classes, objects, methods, attributes. Okay, so you have a class, which is a blueprint. Okay, a class is basically just a blueprint. Of course, these things you know about them already. I'm just brushing through, right? A class is a blueprint of what? Objects, right? Objects are instances of a class. A method describes the behavior of an object. And of course, attributes represents the state of an object. Okay, so that's just that. So these are four things you need to keep in mind as far as you're working with classes, or OOP rather. Classes, objects, methods. So let me see if I can just do small deep dive, right? Classes are basically just user-defined data types that act as a blueprint for your objects, attributes, and methods. Objects are instances of a class with specifically defined data. Okay, with specifically defined data. So when a class is defined initially, the description is the only object that is defined. Methods are functions that are defined inside a class that describes the behavior of an object. Okay, and then attributes are defined, in your class templates. They basically just represent the state of an objects. That's kind of just OOP. Now, there are certain things in OOP that we're going to look at. Some call it pillars of OOP, and there are a lot of terms that you can people give it, right? Some call it concepts, okay? But that is encapsulation, abstraction, inheritance, and polymorphism, okay? So we're going to look at these things, but we'll do it from a coding perspective. So I'll explain, and then I'll show. So I'm going to my Visual Studio Code. Of course, you shouldn't be new to VS Code. You're past beginners already, except you build your applications using Android Studio, but I'm using VS Code. So I have a folder called Flutter Intermediate. I'm just going to create a file called oop.dart, where we'll do some of the things we want to do. Okay, so we're going to start with encapsulation. What does encapsulation actually mean? It's basically the practice of hiding data and behavior of a class from the outside world to prevent, maybe accidental data manipulation. Okay, and at the same time promote security, right? So let's look at an example of encapsulation. So I'm going to create a class called bank account. Okay, and then I'm going to let's create some variables here. So these are the properties, right? Yeah, so all you call them attributes of this class. So every bank account has an account number. Now I'm using an underscore for this because I want it to be a private variable. I'm not going to initialize it yet. And then every bank account, of course, has a balance. So these are the properties. Okay, so I'm going to create a constructor from this. Like I said, you guys should know this already. So there are certain things I'm not going to go through. So this dot count number, this dot balance. Okay, so yeah, so this is just that. Now I'm going to create so because this is a private variable, right? I'm going to create a getter, variable that can be accessed, outside of this class. So I'll just say a double, I'm going to say get balance, and it should get this balance, right? So with this, I'm going to have a function. Let's just create a function to deposit money. So I'll just call this deposits. And of course, to deposit, you have to give it an amount. So I'm going to use a double data type. So how do we deposit? Basically, you're basically just adding money to your balance, right? So we're going to add the amount to the balance. I'm just going to use so I'm going to use this. So what am I doing? I'm adding and assigning at the same time, right? You guys are intermediate, so I hope I'm not losing you. But I'm adding and assigning at the same time. Okay, so we could create a function to withdraw an amount called double, right? And then, of course, to withdraw, first things first, I need to check that what I want to withdraw, I won't have that money, right? So I'm going to say amount, I'm going to check if it is less than or equal to the balance. So I have to do that check, right? If that is true, right? If that is true, then it means I can actually withdraw. So of course, after performing that withdrawal, I'm going to withdraw from my balance now, right? So I'm going to take and at the same time do this. So if that's true, but if it's not, right, it means that I actually don't have money. So I'm just going to print insufficient balance. Insufficient balance, right? So I'm just setting this up so I can explain that. So now let me just get my main function. Let me create my main function because we need that as an entry point. But that should be done outside of the class. Yeah. Yeah, so I'll do that outside of the class. So I'm going to get an instance of my class. So I'm creating an object right now, which of course you should know. So I'm creating an object. And then the account number, well, I'm just going to say 1, 2, 3, 4, 5, 6, 7. And for balance, let's say I already have 5,000 there, right? So I've created an object. So sorry, 5,000 is actually a double, so it shouldn't be in a quote. So now with my object, I can have access to deposits. So how much do I want to deposit? So let's say I want to deposit 2,000, right? Now, after that, I want to print something. So let's say I want to print the balance. So you can see I have access to, now, if you notice, I have access to both of them, but I'm not supposed to have access to this private variable. But the reason I have access to it, of course, is because we are still in the same file. So I'm going to do something. I'm just going to leave it, right? I'll run it, and then let's just see what our balance is. So when I click on run here, so you can see we have 7,000. We had 5 before. I deposited 2,000. We now have 7,000. But I shouldn't have access to this, right? And like I said, the reason I do is because I'm still operating in this file. So I'm going to cut this, and I'm going to create a new file for my main function. I'm going to call it main.dart. And I'll paste my code there. And of course, as you know, since we are now calling a class, we can import that class, right? So I'm just going to import it, and then I have access to it. So you can see now it throws out an error because it's saying the getter underscore balance isn't defined, right? So I can just use this one that I was defined. I made open and accessible to, every other person. So that solves that. So the concept of encapsulation there is that we are able to encapsulate the account number and balance variables by making them private. Okay. And then providing public methods like the deposits and the withdraw, and also this balance, okay, to interact with these variables. So we are actually interacting with the balance, right? But not directly. Okay, not directly. Okay, so that's the concept of what encapsulation. Now, we have the second pillar. Let's use the word pillar. Like I said, there are some people use concepts of OB, some person say pillar. So let's use pillar. So the second pillar we're going to look at is inheritance. Okay, so inheritance allows a class to inherit properties and methods from another class. And this actually helps you to promote code reusability, right? To promote code reusability and organization to kind of, so let's create another file called animal. I'm going to use that animal.dart. So let's create a class called animal. Now I want to give this, I want to say it has a function called make sound. So as an animal, every animal can make a sound, right? And in this make sound, I'm just going to, let's just say print generic sound. Okay, so we have this class, right? Now, inheritance means that I can inherit. So from the word inherit, right? So let's say um, someone whose father dies and leaves the mansion to him. So he inherits the mansion, right? Or let's say a company. I like to use company as an example to explain inheritance, right? So a young man whose dad has a company, a marketing company, or a company basically, right? An organization. So when the father dies, right, he inherits what the father what has. He inherits that company, meaning that he has access to everything in that company. But at the same time, because he has access, he can basically also override certain things. We'll talk about override in programming. But the concept of override means, okay, there was already a marketing department, for example, that they had a particular way they do things. Override means, okay, I come to that department and I change the way they do things. Now I can now do it my own way, but there is already a marketing department. Okay, I'm not taking it out, but I am overriding it. Means that I want to do something else, or I want it to be done in a different way. That's the concept of inheritance, right? So we have a class called animal, and every animal makes a sound. That's the function there. Every animal makes what? A sound. So I could create a class called, let's say dog, and I want to inherit the function. I want to inherit from the animal class. So I'll use the word extends, which is a keyword. Extends what? Animal. Now, the moment I do this, it means that I have access, okay, to this young man here. So I could say, I could also just call this function, just to, save time, and then use the override keyword, right? So what this means is that I'm overriding this make sound, and I can decide that I don't want to print generic sound. I want to print dog sound. I want to print a bark sound. So that's inheritance. Okay, so can we test this? Of course we can. So we'll use our main .dat to test everything we want to test. So I could say final dog, small letter, and then I creating an instance of dog. Remember, we have dog as a class here, right? So I'm creating an instance of it. Okay. Now, so I can now say dog dot make sound, right? And this make sound is from this word function. Okay, so when I run this, forget about this balance, right? You can see backward sound. So I overrode the what's it called? Let me close this. Oh, okay. I overrode the animal. Yes, I overrode this make sound, and I decided to give it what this. Okay, so that's inheritance. So we're basically just doing a brush through. Okay, so in the example I gave, this dog class inherits the make sound method from the animal class and overrides it to provide a specific sound. Okay, that's inheritance. Now, how about polymorphism? Okay, how about polymorphism? So polymorphism, I'm going to be using different instances. Of course, I can use one, but I don't want to, I want to use different instances. So let's say, let me call this instruments.dat. Now, for polymorphism, polymorphism basically allows objects of different types to respond to the same method, okay? They allow objects of different types to respond to the same method, okay? So here's an example. I want to create an abstract class called musical instruments. And this abstract class has a function called play. Remember, abstract classes, you don't really give it, you just define the methods. Now, when you get an instance or where you call those methods, you can kind of use it the way you actually would want. Okay. So how do this is polymorphism. So let's say I have a class called piano. So in polymorphism, we don't use extend. We say it's, that should be PIA. So we say implements. So it implements musical instrument, right? So you can see it says missing concrete implementation of musical instrument dot play. So what do we do? So it's kind of a missing method. So I can just come down here, go to quick fix and create the one missing override, and that's play, right? So I now have to say, okay, what do I want to do with this function? So let me just say print playing piano, right? I could do the same thing for another class, right? Let's say guitar, and it still implements your musical instrument, right? And then what do? We override, can click on this light bulb also, create one missing override. And here in this play, what do we want to do? We want to print something else. So I'm going to say playing guitar. So this is polymorphism, right? This is polymorphism. So the musical instrument interface, right? We use it to create a common play method for both the piano and the guitar classes. So each of these class implements the play method differently. That is polymorphism, right? That is what polymorphism. Of course, I can create an instance of piano, and of course, do I need to do that? Okay, let me just do it. Final, I could just say final. Um, so okay, I can just say musical instrument, right? Piano. So what I'm saying here, I'm creating a variable of or an object of that music, but I'll pass in piano here, right? So what is this piano now? You can see it's now a type of musical what instrument, right? But I am creating the object of this guy. So with this, I can now say piano dot play, right? I'm going to do the same thing, but I'm going to do it for guitar. So we see that, how that works. Guitar. Yeah, so guitar.play. So let me comment this out. So we just see the necessary print statements we want. So I'm gonna run this. So you can see playing piano, playing guitar, right? So that's polymorphism. Okay, that's that's actually polymorphism. Okay, so each class implements the play method differently. Okay, then of course, the last one is abstraction, right? Abstraction. So what does abstraction actually mean? Abstraction is basically the okay, let me put it this way, is the process of hiding implementation details and exposing only the essential features of a class, right? And it's something we actually did, but I'm going to use another file. Like I said, it's intentional. I can do everything with one stop, but I don't want to confuse you. So I'm going to say, let's say I want to create a database. For some of you who have worked with database, you should understand this. So I'm going to create an abstract class called database. Okay, so remember, we hide the implementation details and expose only the essential features of the class. So I'm sure you've seen this before, future. I'm looking for your trouble though, so that some of you will be like, wait, can I still remember this thing? Don't worry, we'll talk. So of course you should know about dynamic data. I'll just say data is the name. So to save, I want to save, I'm creating a function now called save, but it's a future function. This is basically talking about asynchronous programming. We'll get into it. Okay. And then I have another one. Let me call this retrieve. So retrieve, but yes, we use a query, right? So these of type dynamic, it can be anything, right? It can be anything, okay? So let's say I have another class, okay? Want to demonstrate abstraction now. So let's call this my database, and it implements database, right? It implements what? Database. So what happens? Of course, we have to what? Implement this. So we have two missing what? Variables. We have two what? So it hides the implementation details, but it just gives you what? The essential features. And the essential features of this database is what? The save and retrieve function, right? Which you can now implement however you actually want. Of course, this one returns a feature. So you need to what? Implement something. So I'm just going to leave it as to do because I don't want error, right? So that's basically what abstraction. So we define an abstract class called database, right? With a save and retrieve what methods. So the specific implementation details for this my database class will just focus on what the functionality, the core functionality provided. Maybe, right, I have some other stuff that goes on in save, right? But once I override, I can now just focus on implementing what I want to implement in my own what database. Okay. So um so that's that. I know we talked about OOP, right? So let me just, and for some of you, just to reiterate, this is basically just to jog your memory. This class is to jog your memory. From the next one, we are heading into much more serious stuff, right? So let's just remind ourselves, right, of this stuff. So you've seen me write class, 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 and all those stuff in case you have forgotten. So like we said, a class is basically just a blueprint or template, okay, for creating objects, right? And a class defines the state, which which are your variables, and then behaviors, which are your methods. Okay, and objects are basically just instances of a what? Class. Okay, now there are a few things I want to talk about in classes, right? For example, constructors. Okay, constructors. So let me just come here. Just this just to remind you, because so let's say you have a class called class name, or sorry, class called name. Let's restart. Okay, right? So yeah, open this. Okay, so constructors, you have different kinds of constructors, right? And of course, when you're creating a constructor still has the same name as the class, right? It has the same name as the class. Okay. Now, but what is a constructor? Basically, a constructor is just a special method of a class, okay, that initializes a newly created object. Okay, that's basically what a constructor is. It's just a special initialization function that it is actually automatically called whenever a class is what whenever you create an instance of a class or when a class is declared. So it always has the same name as the class name. And of course, there are no data types that are defined for the arguments. Now, but we'll look at some kinds of constructors, right? Just for the sake of what we are doing and in the spirit of trying to remind ourselves, right? We have a default constructor. So this is just a default constructor just has the name, right? For example, I'll just say name. So this is a default constructor, right? It doesn't have parameters. So a default constructor basically does not have, this one doesn't have parameters. We have a named constructor. Now, named constructor means I can now say name dot, right? Name dot, and then I give it a name. Name dot, let's say my name. right? And then, so this is a named constructor. Of course, I can decide to put, parameters, let's say, I can just say, first name, last name, that's if I want, right? So this is a named constructor. You will see, you should have seen, or you will see, you are going to use stuff like this. So this is a named constructor, right? Now we also have a, at the same time, well, we have a parameterized constructor. So I'm probably going to use this one. So this is default, it doesn't have any. A parameterized constructor is one that now has, some parameters, right? Let's say first name, last name. Okay. So these, let me just say names, right? This is just like an example, right, of a parameterized what constructors. I'm just giving you examples, right? Okay, so that's just to refresh our memory, right? Another thing I also want to refresh your memory on is access modifiers, right? When it comes to variables, right? Of course, you should know we have public, the access modifiers we should have public, we have public, right? We have private, and we have protected, right? So public variables and methods can be accessed from anywhere. You don't need any special keyword. Private variables are only accessible within the class, and that's, you can use an underscore to create them. And of course, protected variables, rather, they're accessible within the class and its subclasses. Okay, and you still prefix them with an underscore, right? Yeah, so that's basically that. I'm just kind of trying to bring us up to speed, right? Now, but there's one very interesting thing in Dart called mixins. Well, I don't know if you've heard of this, right? But there's what called mixins in Dart, and they're actually a way to reuse. Okay, someone's hand is raised. Collins, go ahead. You have a question? Hello, Collins. Okay? Yeah, okay, you can unmute now.
Okay, yes, I have a question. You say something about protected and private variables, like, and you basically say the same thing for both of them. So I want to like know the difference. Sorry.
Okay. Yeah. So I said that private variables, right, are accessible only within the class. Okay.
Mm,
Protected variables are accessible within the class and its subclasses. So when I say subclasses, you know where you have a class within a class. Okay,
yeah.
its subclasses can also access protected what variables. So protected variables are available within the class and its subclasses. But
Sorry,
yeah, yeah,
what I'm asking is how you define them,
same way,
how you
underscore,
declare them
same way.
actually.
Once you put the same way, you can just, like, let's say underscore variable, right? Still the same
Mm.
way. Yeah, that's fine.
But then if you define them the same way, how do they serve different purposes? So I'm
That's
trying to
why I said
understand that.
it's all about, it's more of about how they are assessed. Both of them. See what private. Okay,
Okay,
look at it. Look at the word private. Private means that it shouldn't be seen by everybody, right?
okay, sorry, you mean like it's like a developer convention, like it's not really enforced in the language.
Like, well, you don't actually have to now use a keyword or same protected variable. No, 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 no. Now let me
Okay,
explain this.
yes,
Let me
because
explain. Okay, is that what you were thinking? That you probably have to use the
yes,
word protected.
exactly, because to
Okay, no, no,
differentiate
no,
the purpose.
no, no. You don't need to do that in Dart. You don't need to. You don't need to. So
Okay,
what I was
thank you
trying to
very much.
explain, what I was trying to explain is this. So of course, the word private means that is just not, it's not to be seen by everybody, right? That's
Yes,
what the word
yes.
private means. Protected also means that, but with a different, it has a different tweak. yes, it's not meant to be seen by everybody, but there are few persons that can see it based on access. Based on us. So it is protected, means that there are few persons that have. So if I protect something, right, I can decide that,
Yes.
okay, in as much as it's protected, it's only accessible to these two persons, but yet it's still private. So a protected variable is also private, but just
Yes.
more like an added, this, okay, there's this access control kind of thing, right? That's why, let's say like a vault where you keep money, right, is protected.
Yes.
It's also private. Private in the sense that
Mm.
people who come into the bank should not see it, right? And at the
Yes.
same time, they should not even access it. Now, protected in the
Okay.
sense that there are staff that can see it, but they cannot access
Mm.
it. And there's
Okay.
certain staff that can see it and access it, but it is still
Okay. I
private.
understand that.
Yeah.
Understand that. What I'm
Yeah.
just trying to say is, ask is that both can be used either way, since there is no
Yeah.
restriction in how they are declared.
No, there's no restriction in how they are declared. But of course, in assessing,
Is it,
that is
is
where
that,
that's where there's a
yes.
difference in accessibility. Declaration, there's no difference, but accessibility, that's where there's a difference. So outside a class, you cannot access
Yes.
either of them. But if you have subclasses, right, a subclass can access a protected variable.
And
Oh,
you
well,
can
we're
also
going to do,
access the private if you want
yes,
to.
it can. Because both
Okay.
of them
Thank you
use
very
this
much. That's
variable
all.
declaration, the underscore. Okay. Yeah.
Oh,
Somebody's hand
okay.
was raised as the person dropped it.
Yeah, my hand was raised, but
Okay.
because my
Oh,
question was
okay.
actually, if you are declaring them in the same way, how do you differentiate um, a protected and a private? But it seems it's from the usage
Yes.
of the
Usage.
variable that determine if it is protected. Okay, thank you very much.
Yeah. Yeah. Okay, so yeah, let's move on. So I was talking about mixins, right? So mixing basically is actually a class, right? Is a class that can be added to another class as a superclass. I hope I did not confuse you, right? So a mixin is a class that can be added to another class as a superclass, thereby allowing the subclass to inherit the mixins method and variables. I feel like I've confused one or two persons. Okay, so let's just do it in code, right? Let's do it in code. So let's say I want to declare a mixin. Remember I said a mixin is a class, right? I'll use a keyword called mixin, right? If I hover on it, so let me call this login, right? And it has a function to show a log. And of course, a log, you need to give it, let's say, pass a message. And then print message. So here's what mixing does, right? I'm just going to now say, so with mixing, you can now access you add add it to another class as a super class. So what does that mean? Let's say I have a class called my log, and it now extends what? Login. Which is what I just created, right? So of course, we're going to have to okay, yeah, I think you need to, don't really need to, hold on. Okay, so I think I'll do that into, let me just change the name so that I don't get to use a keyword. So it's very, very important that you don't use keywords. Okay, so, yeah. So let me say my log. Okay, so I hope I'm spelling this right. So here I was saying we have this error, classes can only extend this is, so try specifying a different what superclass, because that's the idea of mixing, right? You're creating a superclass, right? So let me see if I can use um let me see if I can use a clearer example for this. Okay. So I'm going to use let me use this example instead. Let's say we have I'm thinking what to use exactly now. Okay, so let's say I have a class called musician, right? And then maybe before, okay, first of all, let me create this. So I have this class, right? So using a mixin, right? Because mixins, they are basically just a way to define your code that can reuse the multiple class hierarchies, right? So we use to use a mixin that has already been created. Let's say, for example, we have a performer. I can say class musician extends performer, which is a class, and then I create a mixin called, let's say, musical, for example. So how do I extend and I say with musical? That's basically what's mixing. So the musical here is a mixing, right? The musical word is what a mixing. So it acts as a super class. Okay, it acts as a super class. So when you want to define a mixing, you basically just use the keyword mixing, right, to what define that. So, well, it's actually in a very rare case that you see one use a mixing and a class, right? It's actually in rare cases, but this is something I just want to introduce. We'll actually use something like this. I think I have a part I have somewhere during our training where we'll actually implement stuff like this. But for now, this is just to introduce you to it. I'm doing just introduction. We'll dive into it and start working on actual stuff. But that's basically what mixins are. It just helps you to define code that can be used in multiple class hierarchies, right? So we just use the keyword with. So we are extending a musician is a performer, right? Is extending, so whatever function that is here, right? So let's say, for example, well, I can have a function, maybe some properties in this, because you need to understand the mixing is also a class. So there are certain properties like probably, let's say as a musical, you can play piano. And I can even set this to false, right? Okay. I can even create a function called entertain me. And then, of course, if I'm doing a function now, I'm just going to say if the person can play piano, then I'll just print can entertain me. So if you can play a piano, yes, can entertain me. So it's still a class, but now it acts as a super class. Okay, it acts as a super class. So that's basically the concept of mixing, right? We're actually going to use it. We'll use it. I'll create a scenario where we get to actually use it and understand it fully. But this just to introduce us to it. Then let's say one last thing. Well, not really one last thing, actually. We'll just run through some. Yeah, we'll look. I'll probably start looking at generics. So let me check out. Factory constructors, very important. Very, very important. You've probably used it, but maybe you don't really know. So factory constructors, a factory constructor is actually a special constructor that allows you to create objects without specifying their exact class, right? You definitely have used this in if you've done some networking stuff, fetching of data and all this stuff. So let's say we have a class called person, right? We have a class called person. Now, so I'm going to say string. Let's say the person has a first name and the person has a last name, right? And then I'm going to just create a constructor so that once I initialize it, we pass in the first name, we pass in the last name, right? Now I can create a factory constructor called person dot, for some of you have seen this before. Now it will throw an error here, right? Of course, but you should have seen something like this before from map, where what I want to do is that I want to get, you've used this before, Sha, you should have. Is there anybody that hasn't used something like this? Then you need to check that your, what's it called? You need to check your whole finally stuff, right? So let's say I'm getting a, what's it called? I'm trying to fetch data, the person's information, right? I can now say, just for this constructor, I can now say first name, right? First name is equal to, I'll say map. So what do I want to map? I want to map the first name as a string. Sorry, that should, yeah, first name as a string, right? I could do that for the last name also, right? Last name, sorry, camel case, very important, right? And then what do I want to return? I want to return, person. This is basically what I want to return, right? So, how do I now use this? Okay, or how do I call it? So it's simple. My main function, right? I'm going to get I'll create an object called person, object variable, and then initialize. I'll give a first name because it asks for. So I'll say Jane, Jane Doe. Okay, so also I can also create an instance using the word factory constructor, right? And what's the name of the factory constructor? Just like we did in the animal, is person dot what from map. That's the name of the factory word constructor. And of course, since it's a map, right? You have to do something like this, say first name. And then what to be the value of the first name is what? Let's say Jane or John, right? Okay. And of course, we also have to do for last name, and John Doe, right? So that's, I think that should be here. Okay, so person 2 rather. So this is a factory word constructor. And the goal of a factory constructor is to return an object. So this gives us what? An object. Okay, so I could now use this, right? I could say print let's say person dot first name, right? And then I could also print person 2 dot last name or first name also. So when I run this, first I should see Jane and then I should see John. So that's just the idea of factory constructors. Okay, they just return an object to you. You use them to return an object instance. Okay. Yeah, so any question? Any question? Let me check the chat. Okay, none from me, none. Okay. Okay, so that's basically that, right? So I'm going to use this class and the next class to brush up on just certain things because we're going into Flutter, right? but two things we need to look at, right, are just the concept of OOP and some of these few things I'm just pointing out, right? So in our next class, we're going to look at generics and asynchronous programming, right? Generics and asynchronous programming, two very, very important things, especially asynchronous programming. Two very, very important things as far as Dart and of course Flutter development is concerned, right? So we'll look at two of them, not from a Flutter perspective, from a programming perspective, right? We'll talk about features and async, await. These are three keywords. Of course, you should know them, but we'll just brush through, right? And then after that, we get into serious stuff, right? We get into serious stuff. So in the absence of no questions, of course, if you have any, you can also just drop it on the intermediate channel, right? And if after this class you've seen that intermediate is not where you're supposed to be, right? You're supposed to be in beginner, do yourself a favor and switch right now. The earlier you do, the better, so you don't stop by the wayside and don't achieve anything. Okay, so yeah, okay, I see a hand raised. Collins, go ahead. I think you can unmute. Hello.
Okay. I have can you hear me?
Yes, go ahead.
Okay. Is more of a request than a question,
Okay.
because I would like to learn about it too. I've been having trouble like learning about it online. Like in addition to the asynchronous programming, can you also like touch a bit on parallelism in that's isolates?
Okay. Sure. But you should
Okay.
you should know it now. Why shouldn't you know that?
I'm having problems like understanding like the whole idea of how it works. That's the isolates. It's not like threads in other languages. It's a bit different, so it's
Yes, I
kind of
know.
new to me.
It's
Okay.
but the truth is, instead of threads, actually, that actually runs inside isolates, right?
Okay.
Yeah,
Threads
instead
run
of
inside an
threads.
isolate.
No, instead of threads, all your Dart
Okay.
code runs inside and isolate. So we'll talk about that. Well, that means we'll have to now talk about concurrency in a bit, but yeah, I'll touch on that. I'll touch on that.
All right. Thank you very much. Thank you very
But
much.
I'll just touch briefly because it's not you should know these things already, but it's all under concurrency as far as that is concerned. So let's see I'll see how we can kind of briefly talk about it and look into it in our
Okay.
next class. But
All
just
right.
know that they are like threads. They are like threads actually.
Okay.
Isolates are like threads, but the thing is that each isolate has its own memory and a
Mm,
single thread that runs an event loop. So let's just leave that
yeah.
to the next in the next class.
Okay.
Yeah. Okay, so if that's all, big thank you, right? So we'll communicate more on the chats on Discord, right? Of course, I expect your tools are installed, your Flutter, and everything is installed. I expect you also have a GitHub account. When I give you a task, right? This is just a heads up in case in case you don't communicate more with Git, right? When I give you a task and you have to push your code, every comment I'll give will be on your Git. You should understand PRs and all those stuff, right? Comments. I'm going to put comments on your codes, so you have to learn how to master GitHub if you have not. Okay, so that's that. Thank you guys very much, and let's have a wonderful week ahead.
Thank you very much. Really appreciate it. Have a nice night.